All right, we're in section 2.3 where we are going to apply deductive reasoning. So in 2.1, we looked at inductive reasoning. So this was from 2.1. When we looked at inductive reasoning, like by definition here, it says it's the process of finding a pattern for a specific case and then writing a conjecture for general cases. When we talk about inductive reasoning is about things that we can observe. Deductive reasoning uses facts, it uses definitions, accepted properties, and the laws of logic to form a logical argument. So, of these laws of logic, we have two laws. We have the law of detachment, and then we have the law of syllogism. So, law of detachment says that if the hypothesis true of a conditional statement is true, then the conclusion is also true. Here it says law of detachment is also called a direct argument. The law of syllogism is a little bit more complex when it comes to trying to discover what the definition is, but really what it means is this, is if you have a hypothesis P and a conclusion Q for one statement, and it's true, and then you have another statement where you have a hypothesis of the conclusion from the previous statement. So you see how I have Q and Q here, and then you make another conclusion from that, and that's also true. We can say that the hypothesis of the first statement and the conclusion of the second statement will also be true. They call that the chain rule. Okay, and so we'll look at both law of detachment and law of syllogism to try to create our logical arguments. So first off, it says use the law of detachment to make a valid conclusion in the true situation. So here it says if two angles have the same measure, then they are congruent. You know that the measurement of angle A is equal to the measurement of angle B. So we can say that because the measurement of angle A is equal to the measurement of angle B, satisfies the hypothesis of a true conditional statement, we can also conclude that angle A is now congruent to angle B. We look at this example here. In this particular one, it says that Jesse goes to the gym every weekday. Today is a Monday. First, we need to identify the hypothesis and the conclusion of the first statement. So the hypothesis is telling us that um, if it is a weekday, and the conclusion would be is then Jesse goes to the gym. So here it says today is Monday, satisfies the hypothesis of the condition, so you can conclude that Jesse will go to the gym today. Okay? Excuse me. It says, if possible, use the law of syllogism to write the conditional statement that follows from the pair of true statements. So we have if Ron eats lunch today, then he will eat a sandwich. If Ron eats a sandwich, then he will drink a glass of milk. So if you notice here, talking about law of syllogism, so we have this is our first hypothesis, and this is our first conclusion. So this was like this to say this was P, and this was Q. So now, with the second statement, we're making another hypothesis right here, but it's talking about the conclusion from the first statement, so I'm going to call that Q. And then drinking a glass of milk is the conclusion here, and we're going to call that now R. So basically, it says the conclusion of the first statement is the hypothesis of the second statement. So now we can write the following. It says, if Ron eats lunch today, then he will drink a glass of milk. Using the hypothesis from the first one and then the conclusion from the second statement. Excuse me. So now here it says if x squared is greater than 36, then x squared is greater than 30. If x is greater than 6, then x squared is greater than 36. So here it says notice that the conclusion of the second statement is the hypothesis of the first statement. So we can now write the following. It says if x is greater than 6, then x squared is greater than 30. Because we had, so like this was our P, this was our Q, but right here we have a R and this is P. So since hypothesis and conclusions were part of it, we can rewrite the statement using the law of syllogism. So here it says if a triangle is equilateral, then all of its sides are congruent. If a triangle is equilateral, then all of its interior angles are congruent. So neither statement's conclusion is the same as the other statement's hypothesis. You cannot use the law of syllogism to write a new conditional statement. All right, for one, you have the same hypothesis in each one of them, giving you uh, true conclusions, but you have to kind of flip those around in order to make that happen. So in this example, it says if 0 degrees is less than the measurement of angle A and is also less than 90 degrees, then angle A is acute. The measure of the measure of angle A is 38 degrees. So use the law of detachment, and what statement can you make? So using law of detachment, you can conclude that angle A is acute because we know it's in between 0 and 90. By definition, an acute angle is something that's in between 0 and 90 degrees. They told you that the measurement of angle A is 38 degrees. We know that angle A is acute. Here it says state the law of logic that illustrates below. It says if you do your homework, then you can watch TV. If you watch TV, then you can watch your favorite show. If you do your homework, then you can watch your favorite show. So this is a law of syllogism because we have our hypothesis P our conclusion Q. We have a hypothesis Q and a conclusion R. So we can say that hypothesis P and conclusion R are all true statements. So we can use the law of syllogism to uh, state this. Here it says you're going to use inductive reasoning to make a conjecture about the sum of a negative integer and itself. Use deductive reasoning to show the conjecture is true. So what we have here are, it says step one, it says what conclusion can you make about the sum of an odd integer and an odd integer? So again, sum is addition plus. So it says look for a pattern in several examples to use inductive reasoning to make a conjecture. So negative 3 and 5 is 2, negative 1 and 5 is 4, 3 and 5 is 8, negative 3 and negative 5 is negative 8, 1 and negative 5 is negative 4, and 3 and negative 5 is negative 2. Okay, so the conjecture that we are going to make is every result that we had came out to be an even integer. So an odd integer plus an odd integer equals an even integer. That is what we observed. So now we have to use deductive reasoning to make sure that this conjecture is true. So now what we're going to do is we're going to let n and m be any integer, whether it's even, odd, positive, negative, whatever it is. And so now this is going to allow us to um, make sure that this conjecture is in fact true. So they're saying that 2n and 2m are going to be even numbers because in any integer multiplied by 2 is in fact even. All right, we know that those are true statements. Now we can say that here 2n minus 1 and 2m plus 1 are odd integers because 2n and 2m are even integers because we talked about that on the top. So here it says if we go 2n minus 1 plus the quantity of 2m plus 1 represents the sum of an odd integer, but now if you had 2n minus 1 and an odd integer, 2n, 2m plus 1. So if we had here 2n minus 1 and 2n plus 1, essentially if you took them out of the parentheses, if you took this out of the parentheses here, you would go 2n minus 1 plus 2m plus 1. These two would cancel out, which now you have 2n plus 2m. And then if you were to factor this out, you would get 2 times by the quantity of n plus m. So because the result is the product of 2 and an integer n plus n, didn't matter whether it was uh, even or odd or whatever it was, didn't matter. So we can conclude that 2 times by the quantity of n plus n is an even integer. So we can now, using deductive reasoning, saying that the sum of an odd integer and an odd integer is an even integer. So the final page here, it says, tell whether the statement is the result of inductive reasoning or deductive reasoning they're asking to explain. So what we have here is a diagram and it says average running speed, where on the left here it talks about average speed in miles per hour, and then in below it talks about time in minutes. And so you're running, if you run, however many minutes you're running, that many miles per hour. So, first question, it says the runner's average speed decreases as time spent running increases. So, if we look at that, the average running speed decreases as time spent running increases. That is correct. So, if you look at this, it seems to go down as the amount of time increases. It is something that we observed. So since it's something that we observed, we are going to say that this is inductive reasoning. And it's because we observe the pattern. We observe the pattern of the data. So we looked at the data, we said, yep, it went down as time increased. That was our observation. It came from inductive reasoning. Here it says the runner's average speed is lower when running for 40 minutes than when it's running for 10, 10 minutes. So if we look at 40 minutes seems to be somewhere in the 7 miles per hour. So let's just say 40 minutes equaled about 7 miles per hour. And what we have here is in 10 minutes, it's closer to 9. Say about 9 miles per hour. So here it says the average speed is lower when running for 40 minutes than when running for 10 minutes. So because 7 is less than 9, the statement they have here is true. We based it off of data. So because of deductive reasoning, we were able to compare values given on the graph. Okay. Here it says use inductive reasoning to write another statement about the graph. So just by looking at the graph, we're going to make our conjecture. And so it looks like, you know, the faster the speed of the runner comes from the less time he or she is running. So we can say the faster, the average speed of the runner, the less time he or she is running. You could also say the slower the average time, the more time he or she is running as well. All right, here it says use deductive reasoning to write another statement about the graph. So we can kind of use this to kind of help us out right here because we used, you know, running speed with 40 minutes and running, average speed with 10 minutes. We can say here using deductive reasoning using the data that we can say the runner's average speed is faster when running for 10 minutes than when running for 40 minutes. Because we were able to use that hard data, we were able to make a deductive reasoning statement of the graph. And that is being able to use deductive reasoning. Hope this helps. Till next time.